Okay, question 27, we're blazing through them now. This one, we have first of all got to simplify this expression here. Don't be put off by that notation, we'll come to that in more detail when we do our chapter on functions, but this is an equivalent to writing f of x equals, so exactly the same thing, just two different ways of expressing it. So now, in order to simplify this fraction, first of all, I want to make sure everything is factorised where possible. So I am going to take the denominator here and factorise it. So I wonder if I can fit it into this space here, so I've got the bit below for everything else. Let's see. 3 lots of x plus 1 over... Now if you can't see how to factorise something straight away, or you don't even want to try, you can obviously go to your calculator and the equation function, go to a quadratic. 2, 7 minus 4 tells me that the first root is a half. Now just think backwards, think what bracket would have given me the root of a half. It would have been 2x minus 1, and then the second one is minus 4, so that would have been an x plus 4 there, and that just factorises it for you. Now the reason you want it factorised, of course, is now I'm going to combine these into a single fraction. I need to have a common denominator, so I'm going to keep this one as it is. I've already got the x plus 4 in the denominator of this one, so I also need a 2x minus 1, which means if I've multiplied the bottom by 2x minus 1, I need to multiply the top by 2x minus 1. Now they have a common denominator, so I can subtract. Be really careful. Examiners love to give you a subtraction, especially when one of the terms is negative, because the most common mistake people do now is they write this. They write minus 2x minus 1, but they forget that if you're subtracting the 2x you get that, but if you're subtracting minus 1 you get a plus 1 there, so please don't fall into that trap. Now if we expand this out, we've got 3x minus 2x, which is 1x, and we've got 3 plus 1, which is 4. Ah, that's nice, because then in the bottom we've got the x plus 4, which will cancel, dividing top and bottom by x plus 4 essentially, giving us 1 over 2x minus 1 as required. Excellent. So on to part B. I've got to find the inverse function here. So to find the inverse function, remember you start by, instead of writing f of x equals, you write y equals. And then you switch the x's and the y's. So you go x equals 1 over 2y minus 1, and now you rearrange this to make y the subject. So multiply up. I've got two options now. I could divide the x down, or I could multiply out the bracket. Well, let's multiply out the bracket, why not? In fact, I'll show you both. Let's multiply out the brackets on this one, making y the subject. So 2y x equals 1 plus x, and y equals 1 plus x over, and we divide the 2 and the x down. So that's the answer. Oh, well, let's write it in this format though. So the inverse function of x is 1 plus x over 2x. Now I'll just show you an alternative here. You could divide the x down first, so you get 2y minus 1, the bit from the bracket is 1 over x, and then 2y is 1 over x plus 1, and then y is, divide both of these by 2, so you've got 1 over 2x plus 1 over 2. Now these are the same, because if I were to take this and split it up, I'd have 1 over 2x, which is that, plus x over 2x, and the x's would cancel, leaving me with 1 over 2. So they're the same thing. Now on to C. Find the domain of the inverse function. Some of you have done this work already, some of you haven't. It's not coming up on the exam, but I'll show you anyway. So the domain of the inverse function is the same as the range of the original function, and vice versa. So if I've got to find the domain of this, I could instead find the range of that, and the range of that is the y values that it takes. So let's think about sketching y for a minute. sketching f of x, I mean. So 1 over 2x minus 1. It's based on the graph of 1 over x, which is that, very dodgily. Very dodgily. But let's think about the transformations that happen. First of all, it's moved one place to the right because of the minus 1. So we have this vertical asymptote moving to 1 instead. So we've got that going on. And then the 2 here means that it's all halved in horizontally. So where that asymptote was at 1, it's now at half, because basically we have to take, from the y-axis there, we have to take all the horizontal distances and halve them. So this asymptote is a distance of 1 away, halve it to get a distance of 0.5 away. So we've got the asymptote at half. Nothing changes vertically. So in terms of sketching it, we've still got the, I think I said horizontal before, we've still got the vertical asymptote there, the horizontal asymptote hasn't changed. So this is the graph of y equals 1 over 2x minus 1. Now, before I start to think about the range of that, we need to just double check the domain of it, because the range of this, of course, is every y value apart from y is 0 here, because we've got an asymptote there. So that would be if we were interested in the whole graph, but we're not. We're only interested in where x is greater than a half. So that's why they've put that, because we've got the asymptote here at half, and we're not actually interested in this bit at all. So we can see for this graph, its range is y, it goes from 0 upwards infinitely. So y is greater than 0. So what that means is the domain of the inverse function is the same as the range of this one, but of course you use x because we're talking about domain. So x is in the real numbers, but x is only greater than 0. Okay. Part D, we're given another function now. G of x is ln of x plus 1. Find the solution of fg of x equals a seventh, giving your answer in terms of e. So fg of x means take g of x and substitute it into f. So where if we take our f of x, which was 1 over 2x minus 1, obviously we're always going to use the simplified version here, not the complicated version. We take our f of x and we replace the x here with all of that, with all of g. So fg of x is 1 over 2 lots of ln x plus 1 minus 1. Now, we're trying to solve that equal to a seventh. So 1 over 2 ln x plus 1, take 1, equals 1/7. Let's multiply this denominator, this denominator to the right, this one to the left. So it gives me 7 equals 2 ln x plus 1 minus 1, add the 1, divide by 2, e to the power of both sides gives me e to the power of 4 equals x plus 1, which means that x is e to the power of 4, take 1. Done.